we get a unexpected break for last 5-6 minutes. Agree? First, am I audible? I think I don't need a mic. Good? Yes, thanks. Okay, that was a wonderful, Bharat. I like, K0s, K8s, Kubernetes or K0s. So today I'll be talking about a Kubernetes where we are, okay, let's get the pulse of how many are know about Kubernetes? At least hands on. Pretty explain. Okay, I can see that. I can move the slides are too much, 2-3 slides. I also prepare for that. As Atul was mentioning, right? We run a Kubernetes on-prem. I'll talk about the why we came into on-prem Kubernetes, the story behind that. I'll take a very good one use case on why we are running on it. Okay, related to that, and that outline is next 20-25 minutes. I'll be talking about use case overview, what is modernization journey, and on-prem container orchestration platform, and technical challenges related to that, and abstraction, which are platform engineering, and day-end operations, and key takeaways. That's on a very high level. First point, like use case overview, right? So the use case I'm going to talk about is modernization of our application estate. Modernization on a very high level. The strategy is that based on strengths of platforms and also a consistency of application deployments, mostly on converting from VMs to containers, and also monolithic to the micro-based services. And wherever it possible, getting into on-prem as well. It's not only for cloud as well. That's on very high level on modernization. We did that, and today specifically I'll be on more towards on the one of the legacy app which were running on monolithic on many VMs. That could be due to what confidentiality. I will not talk about the application name or how many of the VM size, all this, but as a nature of that application, it was running on monolithic and many VMs. And when you run on the monolithic, right, the scalability issues, challenges, and moreover, we need to maintain the hygiene of the estate. Like you have to keep talking about, we have to take care about node OS patching and vulnerability management, and also more importantly, it takes more time to market. That is where we, as an organization, we thought of getting into modernization. So we looked at approaches and we finalized on, let's go with the Kubernetes. And it's Kubernetes, yes, it's a buzzword, but it also comes with the cost. So that is where we, for this application, whatever the app I'm going to talk, right, because of the data localization and the customer policies with the thing, we wanted to have it on-prem itself. So that is where our journey started, and we started building Kubernetes on-prem, and we also on-prem Kubernetes, when we start trying to write, we also looked at what are the competencies and also what are the vendor products also available. I will be also talking about that, and why we end up in building our own container orchestrated platform. I call it as COP, container orchestrated platform. That's one thing, and it's not only one thing. And while we started this journey, in between we also had one more application which was running on earlier on public cloud, and then we took that and migrated that into the on-prem as well, and we achieved a significant cost as well. That will be also another point. So the modernization journey, like first thing is on definition, and we have to have why we need it, what we need it, how we are going to do that, which I just talked on that. And models, as I said, right, when you are setting up in on-prem Kubernetes, right, there is a VMware Tanzu product is there, and also Google Anthos, Apps KubeSphere, and then native K8s, which is our CNCF vanilla Kubernetes. So can I use CNCF on Kubernetes? Yes, but how I need to use that? I also need to talk about, I know when I trying to use Kubernetes on-prem, I need to have some standards. The standards could be on how I'm going to support my security, how I'm going to provide my infrastructure, how am I going to provide scalability. When I have availability, scalability is not only on the pod level, which is HPR, VPA, and also need to provide dynamic scaling of nodes and dynamic scaling of nodes and also downstream, and how I provide out of the box logging and monitoring and security. All these are, we have to define that models and start working on. That is where the implementation. So we started on-prem and so just a very thing like implement those things and enhancement. All we did when we started implementation, right? We started, for the beauty of this product is, right, we started with one product. In between another in internal demos we also do that, right? Some other product teams and applications were interested, and why don't we thought like why can't we enable this, extend this into our platform organization and start providing the abstraction. So that is where in between when we are doing the implementation, right, implementation M3 stage, we converted our product as a platform product, provided multi-tenancy and provided isolation. That is where we also became part of the platform team. So we had different on it. That's a journey. We started that, and this is about me. I am, see, Atul already mentioned myself, Shyam. What I do, I work for currently a company called TransUnion, which is a credit bureau company, and I also work for TCS, Dell, JP Morgan Chase, and I'm currently working for a platform engineering for infrastructure thing. And if I'm not part of, if I'm my hands on with not with laptop, what I do, I love drives, I love driving, and also I support my family, and I love cooking and purely veg. So if you ask me anything on non-vegetarian cooking, I won't be doing it. So that's on about side. So this is an overview of Kubernetes. I can see that many people of here already know on Kubernetes. I'll be skipping this slide. So benefits of containerization, that's I just on a high level dynamic auto-scaling of it, and improved redundancy and resiliency, and decoupling application wherever it runs. You no need to have underlay dependency of it. So let's have a little bit on, this is on-prem container orchestration platform architecture and a very high level. If you see on the left side, right, this is where the platform engineering, platform as a platform, right, people thinks that it's a additional layer on DevOps and a tool which works in a box for DevOps tools like GitHub or Jenkins or Bitbucket, Ansible, all this. But the platform is like a product. It's not like collection of services. You need to consider platform as a product. So which will provide you a development component. Developing components provides you to, from inception of your application idea to deploying into production and maintaining that entire life cycle, provides a product. That product is platform. We no need to limit ourselves for platform for a CI/CD or anything, something like that, but it's a product which gives you the complete thing. But in this our particular case, right, more towards on you can talk on this like Git, CI pipelines, IAC pipelines, Ansible, private registry, GitOps, logging, observability. All these are a platform product, platform engineering part of it. And if you see that, right, in the main where we are running our Kubernetes here, if you see these all Kubernetes things runs on top of our private cloud, which is on-prem data center, we also call it, right. If I double click on Kubernetes as a Kubernetes product as a thing, right, We know all about API, kubelet, kubeproxy, but actually in Kubernetes, what it contains internally. We have two things. One is on control nodes, control plane nodes are masters, other one is our worker nodes. So if you take any of it, right, you have a node OS, which is node operating system. As maintaining it on-prem, right, we use any of operating system, either Red Hat, either Alma or Ubuntu, whatever it, right. Node operating system and container runtime, and we have a Kubernetes layer which is consist of APIs, kube schedulers, kubelet, kubeproxy, CoreDNS, and whatever it, right, that's a Kubernetes layer. And we have, as I said, right, we have to provide out of the box logging monitoring. This is another stack. We have network components. If you talk about Kubernetes, right, in my opinion, Kubernetes is all about networking. If you are an expert in networking, you know Kubernetes very well. There is no doubt on it. So networking stack, either ingress class, how do you support our ingress, egress, other, and also Calico policies, networking policies, and finally where you deploy application pods. If you see on this, right, as a platform, right, we are the responsible of node operating system and runtime security, Kubernetes layer, logging, monitoring. These are all platform team responsibilities comes under, because we are providing as a platform. So that is why I call it container orchestration platform. So these are the platform team responsibility. Application comes and deploy it. So how do you application deploys, and how as a platform we maintain this using platform engineering ecosystem. Platform ecosystem, we maintain all of this stuff. Everything is automated, and we use most of, not 99%, most of our ecosystem built using CNCF toolset itself. That's one beauty of this architecture. That's other side. And applications, once you deploy it, right, how I access that application. Internally we use kube, SVS, these commands, but the point, like, we use another network layer. It is managed by the different team, network layer. We expose our services cluster using the network layer, either layer 4, layer 7, and then end users will access via this. This is on the end user perspective, and we have here in between our firewall security team. All this comes into picture, but I am not completely added it. That's one. And as I said, right, in between when we started this journey, we became part of the platform. So in platform is all about abstraction. Underlay application teams or product team should not worry. That's a platform team manages of it. How do we provide tenancy? That is where our abstraction layer comes under. We use Rancher for our abstraction layer that provides the multi-tenancy, RBAC, single pane glass view, authentication and authorization perspective. Any question on this architecture?
What did you mention for the abstraction layer here? Rancher?
Yeah, Rancher. SUSE Labs, SUSE's Rancher. So while I setting right, when we set up on-prem container orchestration Kubernetes platform, the challenges, infrastructure. So we have to provide infrastructure HA from the design of how I have physical infrastructure high availability. So that is where we have this, if you go into the public cloud, right, zones concept. How do we design zones, multi-zones, multi-sites, multi-regional? That's the first thing. And next thing is on how do I provide high availability for control planes and high availability for worker nodes. And when we do the high availability for worker nodes, right, I also need to talk, when we're designing that particular step, we also need to talk about how are we going to maintain that worker node operating system hygiene as well. Because it's not one-time activity, I'll create infrastructure and then rest of the things I'll leave it. No, we have to keep maintaining of hygiene of that infrastructure as well, right? Operating system or estate, how we provide it, how we provide pods availability. Yes, there are multiple things like, we provide is HPA on it, and how we tell app teams that we have to create a kind of a policies without minimum 2 replicas, which not allow them to deploy it. Those are small things, but makes a lot. So how do we create that setup once? And when it comes to the security, right, security on different layers, I'll take you know I'm sorry. Here if you talk, right, I just it's fine, it's okay. Security applicable in each component side, like if I talk, right, node OS, what is the security, like how there are security for CIS. How many heard about CIS? CIS, that's a Center for Infrastructure benchmarking. So there are CIS benchmarks. If you go to cis.org, right, you see benchmarking for GKE, EKS, AKS, OKE, and also vanilla Kubernetes benchmarking is also available. There are plenty of, I think 171 rules, securities, like the security is starting with on how you design your operating system, what kind of pseudo permissions you define, what is the file system layout, and how do you audit those things, and those from starting there itself you have so many security of it. And also you will also find a security at Kubernetes layer, how you design vanilla plain vanilla Kubernetes you cannot install as it is. You need to start writing your hardening rules. Hardening rules you have to define, you need to deploy it. That is also one more layer we are conducting on logging, monitoring, and other point is on application deploy, right. We use policy agent, which is OPA, open policy agent, gatekeeper constraints, you must aware. So defining those policies from the CIS benchmarking will do that a lot. So some constraints are nothing should be deployed on the default namespace, and nothing should be deployed with the root level privileges, no host path, and no root level accesses, and those are many. I am just talking on a few of the points of it. That is a security thing. And how do we provide container runtime? So there are security wise, right, you people think like DevSecOps, yes, from the lift shift time onwards we will have the CI/CD pipelines, all this, but after the application get deployed, we also start looking at how do we have runtime security for that applications. So probably I create an app and I deployed on January 1st, and I am sitting on now May 24th, right. Last 5 months there is no major development and there is no bug, customer features or anything. It was just running as it is, but underlay that application when it has the underlay packages dependency with the system libraries or other libraries may have the vulnerabilities detected. So how do you provide the vulnerability scan report, vulnerabilities and container runtime? So that's provide runtime security as well. You need to start deploy that as well. That's a one thing. And when I talk about networking, right, I'll take that slide little bit later, but that's connecting with our abstraction layer as well. So enhanced user experience, as I said, like we use Rancher for the at that abstraction layer, which will provide a single glance view and provide RBAC, which also has API integration, CLI and GUI. So when I said RBAC, so application development team may require elevated privileges for lower environment, and they need a one place where can deploy and view their application logs and also start looking at monitoring as well. That is where it provides on the thing. And at the same time, application DevOps engineer will have little bit elevated privileges comparing into lower environment. In the production they will have a different roles where it also integrates that. That's one thing. And logging and observability, that's another. Out of the box we provide, that is where when we provision an infrastructure, we deploy our logging agents and observability agent. So that means as the application ready to deploy their application, as soon as they deployed at birth, the logs and observability stack up and running, it start providing it. And also we will define predefined dashboards. So as soon as they onboard, they get access to the dashboards and they can do the rest alerting on their own. They can do that. And app deployment, right? When it comes to the app deployment, yes, one of the industry going towards is GitOps, which is commit based deployment. As soon as you commit something into your source control, which will reconcile and further deploying into the application. So this GitOps deployment, right? So this is a little challenging here because you have Kubernetes deployed and we have source code control deployed. If you look at GitOps, right, and if you go into the market and CNCF, we'll start look at either Argo CD or Flux CD. So there are standard documentation available, plenty of code is there where Flux CD directly connecting into GitOps. You just control, you have 1, 2, 3 steps which you deploy Flux CD controllers like image controller, source code controller, customization controller, notification controller. Similarly for Argo CD. But as I said, so if you go into the architecture, right, where there is no application user directly interacting with our Kubernetes layer. This is all happening through abstraction layer. So that means this Git should connect to Kubernetes via abstraction layer itself. So this is a third, like one more thing came on top of it. So how do we onboarded on it? That's something our custom built framework for smooth deployment, we defined it, right? So this is where Rancher comes, and we defined our own controller agent webhooks which connecting into tenancy, and the tenancy will talk to different source controllers and do the reconciliation on commit based. These are all happen. And other point is automated bootstrapping. I talk resource management and scalabilities. That is also one more point of it. So resource management, as you are in a tenancy model, right? I cannot provide my complete, so I'll talk on the tenancy, right? Let's take an example of, I have, so as I said, we have a legacy application which deployed into here. In between, we had a tenancy on it, right? So there is a one customer application. They need only, they have only 10 microservices. That microservice usage is only approximately, let's say, 50 CPUs. 50 CPU and probably a 60 gig memory. For this 50 CPU, 50 is too much, I said, like for 10 applications, probably a 20 CPU or 24 gig memory of it, right? It's not heavy. For even that application to deploy on any of our public cloud, still you have to maintain control. I cannot provide a zonal, single zonal Kubernetes cluster because zonal uptime is, you all know, 99%. If it is down, how quickly you bring up that in a different zone. It is also that application also connecting into our RTO, recovery time objective, and those comes into picture, right? That is where if you have 4 nines or at least a 3 nines, what we do, we go with the multi-zoner or regional deployment. Correct, agree, right? So, but the cost is expensive for my application. Actually speaking, I need only 20 CPU. But in order to Kubernetes to run the 20 CPU of worth of application, we have to have your security stack deployed. You need to have your login stack deployed. You need to have your monitoring observability stack, and also networking stack, container security runtime. So if we have all this other additional ecosystem, the 20 CPU will become like a 40, and I am unnecessarily paying for different zones. We don't know, like I go to the standard Google or public cloud documentation. If you want 3 nines, 4 nines, go with the regional multi-zonal deployment of it. But actually you need only 20 CPU, but I am spending a lot of money on it. Why can't those use cases are considered when we are creating our on-prem COP, which is container orchestration platform, right? That is where our multi-tenancy came. We introduced that, and in a same Kubernetes cluster, we created different tenants, and tenants provides RBAC and network aliasation by default. No communication between the tenant. Global deny policy. That's the deny. Allow deny. Default deny. If you want to enable it, you have to start writing your networking policy that to communicate between the namespaces. I am getting a sense from Atul to time up. So I'll try to close that, Elri. So with the multi-tenancy, the 60% of our ops cost reduced, that's a one point. And operations, I was saying on management, how do you the management, we have to write a code which will provide the management layer, continuous improvements and the key operational thing, right? Node-wise patching. Abstraction, as I said, right, it's a role of platform engineering, main tenancy-wise, and also it provides the usability because integrated into other CI/CD ecosystem and platform, right? It provide more enhancement, and also more importantly, once we have this connecting into our platform, right, we can streamline our operations. So no, nothing will unthinking. And main important, right, the conclusion key takeaway is on DIY, do it yourself, using our CNCF ecosystem and things, right, we can do it. Only thing is you need to have a commitment platform teams and invest in people and skill set and invest in automation, and then you see significant reduction in infrastructure footprint from monolithic to when going into the application deployment into microservice, and more when coming to the public cloud, right, you have the low cost here, 60% I can guarantee of it. Thank you. If you like to connect, I am be around here. Any questions?